Hello everyone, this is Usman Imam. Welcome to my channel Need to Know. In this video, I'm going to tell you what you would need to know about the unmanned aerial vehicles, UAVs. Unmanned aerial vehicles, known as drones, are powered aerial vehicles that do not carry human operator. Use aerodynamic forces to provide the vehicle's lift. Can fly autonomously or be piloted remotely. They are expendable or recoverable. They can carry lethal or non-lethal payloads. They were primarily made for surveillance and reconnaissance. Then military uses took the lead. Now a broad spectrum of uses are carried out by UAVs: commercial size monitoring, utility, infrastructure monitoring, agriculture, herd and livestock control, firefighting, and so on. The list is too big. Before diving in UAVs technology, we must highlight concerns led to regulation to fly them, especially for drone hobbyists. The concerns are: do not fly higher than 150 meters from the ground. Must fly it away from the people at least 20 meters away. Fly on the daytime. Fly one drone at a time. Do not fly at populous area. Do not fly above utility area. Keep your drone on your line of sight. Aerial frame structure of the UAVs is made of lightweight and durable materials such as carbon fibers composites, which provide a high strength to weight ratio and enhance efficiency, range, and maneuverability. UAV's airframe configurations are either fixed wing or rotary wing. This is the rotary wing configuration. It could be quad rotors or the multiple of even number of rotors. And this is the fixed wing configuration. UAVs power plants. A variety of power plants are used depending on the use, range, and load to be lifted and altitude. A subset of UAVs are powered by gas engines, while they are especially prevalent in fixed-wing drones and military UAVs. A range of engines can be used: piston engines, hybrid engines, turbine engines, and electrical motors. UAVs power plants examples: Admiral 125cc, Admiral engines are dual-cylinder double-stroke engines with fuel-to-oil ratio 32:1. Fuel is 87 and 93 octane gasoline. Weight is 2.682 kilograms. Chinese B2H70. Two-stroke dual cylinder engine. Displacement is 70 cc's. Weight is 2.88 kilograms. The power is 5 kilowatts. Fuel to oil ratio is 40 to 1. The fuel is Jet RP3. German 420 HF. Two-cylinder dual stroke, 183 cc. Impressive power to weight ratio. Weight is 11.5 kilograms and very reliable, 10 kilowatt power. Fuel is kerosene based fuels like Jet A, Jet A1, JP5 and JP8. United Kingdom AR628R. Twin rotor Winkel rotary type. Capacity is 284. Power 67 kilowatts. Weight 56.5 kilograms. The fuel is avgas. Ukrainian AI PBS 350. The most powerful turbojet engine of thrust 3200 newtons, 5 kilowatt electric power, weight 51 kilograms, length 70.6 centimeters, diameter is 29.8 centimeters. Jet is Jet A. The fuel. The specific fuel consumption is 0.12 kilograms per Newton per hour. Used for both UAVs and cruise missiles. USA Honeywell turboprop TPE 331 series. Power range of power from 429 up to 1230 kilowatts. A group of fuels are used in this series of engines: Jet A, Jet B, Jet A1, Jet P1, Jet P4, Jet P5, Jet P8 and Jet P8 100. USA Pratt and Whitney Turbo Aero. Turboprop air breathing engine. The fuel is Jet A or Jet P8. The power is 150 kilowatts. Electrical motors. AM 6600. This type can be used for fixed wing and rotary wing. The power assigned in kilovolts depends on the weight to be carried. United Kingdom V10L, designed for vertical takeoff and landing. Power 170 kilovolts. Hovering thrust is about 22 kilograms. VVVS, used in fixed wing only. The power assigned in kilovolts depends on the weight to be carried. Hybrid engines composed of petrol engine and electrical motor. Petrol engine is 50 cc electronic fuel injection, weight 4.7 kilowatts. Electric motor 2.1 kV kilovolts plus a battery as a booster. UAVs are propelled by twin rotor, twin props, tri-prop, or quad prop. UAVs navigation and control systems. The navigation and control systems consist of ground station, on-board equipment, peripheral devices, and software. Ground control systems, either station or mobile, composed of monitor or monitors, data link, joystick or joysticks, and a control station modem. On-board and peripheral devices include autopilots, data link, camera, infrared sensors, LiDAR, dual GNSS compass, GPS, external magnetometers, flight data recorder, and jammer. This is a typical ground control station for UAVs. Anti-drone countermeasures. Anti-drone mobile jammer, anti-drone radar equipment, portable anti-drone detection and countermeasures equipment, and drone anti-detection equipment. Swarm systems, in the context of UAVs, refers to a coordinated group of multiple drones working together to achieve a common goal. In military and research settings, UAVs can operate in a coordinated swarm using decentralized communication and decision making to execute tasks cooperatively. It is inspired by biological systems like birds flock together or ants coordinate their activities. Fixed wing swarm. It could go like this: a group of coordinated UAVs, or fixed or rotary wing swarms like this. A swarm system features: does not need a single operator for each drone. Each drone in the swarm has some level of autonomy, allowing it to sense, communicate, and act without needing human inputs. cooperate to execute the mission. This cooperation is achieved through real-time communication between the drones. Inherently robust. If one or several drones fail or destroyed, the others can continue the mission without any significant disturbance. Can add or remove a drone from the system. Examples of UAVs. United States of America MQ-9 Predator or Predator. Span 20 meters, length 11 meters. Power plant is TPE 33110. Altitude approximately 50,000 feet. Endurance 27 hours. Takeoff and landing means it is recoverable. Russian Sukhoi S-70 Okhotnik B. It's 6th generation stealth UAV. Powered with AL-31F turbofan engine. The same engine powered Sukhoi 57 and the Chinese J-20. Wingspan 20, length 14 meters. Range 6,000 kilometers. Russian Alt-Yusro. Power plant twin 375 kilowatts VK 800 turboprop engine. Altitude 10 kilometers. Endurance 24 hours. Also it is takeoff and landing UAV. Chinese Winglong 2. Power plant turbo charge engine driving a tri-prop. Wingspan 20.5 meters. Length 11 meters. Altitude 10.9 kilometers. Endurance 32 hours. Takeoff and landing. Russian-Iran Kamikaze Shahid Kupla. It is a ground-launched drone. Wingspan 1.21 centimeters. Length 0.95 meters. Endurance 30 minutes. Not recoverable. Chinese CH-5. (75 kilowatt power plant). It has two variants: strike variant with 24 hours endurance, reconnaissance variant with 21 hours endurance. Wingspan 18 meters and length 8.5 meters. Takeoff and landing also. UK MQ-9B Sky Guardian. With 135 kilowatt power plant. heavy fuel engine. Wingspan 17 meters, length 7 meters. Maximum altitude is 7.62 kilometers. Endurance 40 hours plus. Takeoff and landing also. Turkey Bayraktar TP. Australian power plant, Rotax 912, 75 kilowatts. Fuel is gasoline. Wingspan 14 meters, length 8.35 meters. Maximum altitude 27,000 feet. Endurance 27 hours. Takeoff and landing also. Solar powered UAVs. High efficiency, flexibility, and high weight to light ratio are the main characteristics for solar cells required to power UAVs. Solar power to area ratio is an important metric to consider, as usable surfaces for cells are limited for UAVs. A combined solar performance index for UAVs had been proposed by photovoltaic developers, which takes into account both power to area ratio and power to mass ratio, since high values of both are extremely desirable. The proposed index multiplies both ratios and takes root square of the product to provide an output dimension of watts. A thin film of gallium arsenide is a newer technology that provides lightweight flexible cells with high conversion efficiency and high energy yields. Efficiency is about 68.9%, which is 3 times the efficiency of normal solar cells. This is the gallium arsenide thin cell. Gallium arsenide thin films are less sensitive to air and moisture, and their small size makes them easy to integrate more than any other cells. Conclusion: UAVs meant for surveillance and reconnaissance, then turned to military tasks. Project-oriented design. Non-inhabited vehicles. Cheap and easy to build compared to high-tech aircraft that carry out the same tasks. Can carry lethal or non-lethal payloads. Endurance and military payloads are crucial. Solar-powered UAVs are emerging with flexible, thin gallium arsenide cells. Soon UAVs would become the cheap piece of technology that would shelve many expensive high-tech aircrafts. Well, if you like my video, please give me a like, share and subscribe. Thank you.